Welcome to the STARR Coalition podcast. This is Luke Kramer, the Executive Director of the STARR Coalition, where we get together every now and then and talk to thought leaders and movers and shakers within mental health. And I'm very excited today to have Brad Martins with us. Brad Martins' PhD and working on his MD, but his PhD is focused on neuroscience and neuroimaging, and of course training to become a psychiatrist someday. Why all of this stuff?
I know. Well, first, thank you, Luke. I'm very excited to be here. Why is a good question. I ask myself that all the time.
I'm sure you do. Studying as much as you must be studying, you have to ask yourself often, what is all of this?
So the real answer would be that I want to go into medicine. I want to do psychiatry, but I've always been interested in the mind and how it works. And the truth is that we don't really know how it works when it really comes down to it. We have ideas and we have models, but we don't know what's going on, and that problem just fascinates me and kind of drives me in what I'm doing.
I guess people can go into science because there is an answer to things, but people, I guess, can also go into science because there is not an answer to things.
Yeah, I'd say that most of us scientists hope that there's an answer. But we all, I think, go into it because we want to help find that answer.
Right. So tell me a little bit about, so neuroimaging seems to be, I guess, the on the forefront of being able to look into the mind in ways to specifically pinpoint repeated patterns that could be markers for certain types of indications.
Yeah.
Wow, I sound like I know what I'm talking about. That's really good.
Great, yeah.
Oh, thank you. Wow. So, but go tell us a little bit about what is it that you do? What is it? What are you seeing nowadays?
Sure. So, I guess let me back up a little bit and let's talk just a very brief amount about kind of the history of neuroscience.
Please.
So, when we started realizing that the brain is what's kind of controlling us, that's how we perceive the world and process information, it started with people thinking that specific shapes and areas of the brain coordinated with specific functions. That's kind of, if you've heard of phrenology. Phrenology, which was mapping out shapes, the actual shape of the brain to specific functions. Mm-hmm. And then from that, we kind of found that there are specific areas that deal with more specific functions. You might have heard of Broca's area, which deals with language, and you have the visual cortex, which of course is vision. But what neuroimaging has really allowed us to do is that the brain really isn't as functionally divided as we thought. All these different areas are working in coordination with each other to process the information that we perceive every day. And it's really more about how all of these parts of the brain are communicating with each other that is where things like mental illness stem from. And so neuroimaging has allowed us to kind of map these networks in the brain and kind of see how are changes in communication of these regions related to mental illness.
I was lucky enough to be a guest at the imaging center that you have in the basement of UAMS at the PRI. I remember talking to a couple of the guys that were down there, and they were talking about neuroimaging. And working in the field and not knowing a lot about the neuroscience of it all, but knowing the emotional piece of it, that I've seen, I don't want to call them behaviors, but I've seen symptoms manifest themselves differently in different individuals, but yet does it fall back on being equal parts of the brain that are firing or activated? Let's say for depression, right? I mean, obviously you have different degrees of depression, and maybe that manifests itself different in different individuals. But when we go back to the physical brain, are we seeing the same thing working in the brain, even though it may manifest itself behaviorally or otherwise differently?
So if I think I'm understanding your question correctly, yes, like if you compare like a depressed person to a non-depressed person, right? There are parts of the brain that are more active and less active in the depressed brain than the non-depressed brain, we like kind of treat those as kind of biomarkers of depression.
Right.
But like I was saying, what is becoming more and more clear is that these brain regions it's how they are interacting with each other that's really what's different. So if you think about somebody who is depressed and the things that they're going through, the interaction between their environment and how they process the information and then how they then feed that back to the environment, that's all different because everything is working in like a feedback loop, so, and that reinforces particular behaviors, and the networks then change to adapt to those behaviors, and the behaviors then adapt to the networks, and it just feeds and feeds and feeds, and so you get kind of the like activation and deactivation biomarkers, but that's not the cause of it.
Right.
If that makes sense.
Yes.
It's these changes in how they're communicating that's the actual cause.
Because I remember that you guys were doing a real-time feedback loop as you were, for instance, someone was in an MRI, correct? And they were looking at specific images, that you were able to, in real time, as the brain was responding to these certain images, being able to produce stimuli that can actually counteract that or reduce anxiety and so forth. So you have this immediate feedback, which was fascinating, right? So you can imagine that feedback loop. If somebody were in a depressive state and then they kept reinforcing that depression with environmental things, it would get worse and worse and worse and worse. How do we kick that cycle back the other way?
Exactly.
So now we begin to look at the brain in such a unique and precise way. What are we hoping to garner from that information? I mean, how are we going to translate that into therapies and to whether it be talk therapy or environmental stimuli or medications? What are we wanting to do with this information?
So I think there's a couple of different things that we want to do. Two of the really big ones are we would love to be able to take somebody who, let's say, has a family history of depression and maybe has gone through some traumatic experiences in their life, and so they're very high risk for depression. Put them in a scanner, and we have a general idea of what the depressed brain looks like, and we can say, okay, you are just set up to have depression. We can then, prophylactically through either therapy or potentially medication, work to just avoid actually having depression because, it's once you're in the middle of mental illness, it's much harder to treat than if you tackle it right when it starts.
Right.
So being able to address it either before or right when it's beginning, it would be beneficial. The other thing that a lot of people are working on is predicting treatment response to medication.
Mm-hmm.
So actually, I know in PTSD specifically, and I'm pretty sure in schizophrenia as well, we have found that the brains of people who are respond better to treatment are wired a little bit differently than those who don't, even though they have the same disorder.
Mm-hmm.
And so being able to predict that then can help us as clinicians figure out what track we need to have this person on. Is their disorder treated with an SSRI, they're good to go, or are they going to be, in cognitive behavioral therapy plus medication every day for the rest of their life, and being able to just establish that early on and not have people go through, 5 to 10 medication trials that fail before they actually are getting on something that works.
That's very common too. I mean, it's common that people will cycle through dozens of different medications and dosages, and just to find that magic combination. And for many people, the magic combination doesn't exist right now, right? That's why we focus so much on more cutting edge research. Do we know how early we're able to detect some of these patterns within the brain? Because, they do say that a lot of times people do have a predisposition for mental illness, and sometimes that's triggered by trauma or maybe some other factors like you had mentioned. How do we know how early we can go back to be able to start finding these markers?
So the short answer is no.
Okay.
So what's interesting is that every study that kind of begins earlier and earlier and earlier has found things that seem to predict. And so the lab at UAMS, the Brain Imaging Research Center, or BERC, they actually did one looking at mothers and then and their infant children to see if there were predictors there. And they actually did find a couple that it was more with the mother than the child, but that seemed to predict, I think it was opioid dependence.
Mm-hmm. Wow.
And so, there are big studies going on right now. One is the ABCD, the Adolescent Brain something development study.
Mm-hmm.
That is actually one of the most promising studies that's happening right now, because it is taking children, I think they're beginning at around age 8, and they're following them for 10 years. And they're just seeing how these children progressed with pretty much every environmental, genetic, just every factor, economical factor that you can think of.
Mm-hmm.
So that we can tease all of this apart and
Wow.
figure out where does it start, because we know that mental illness usually appears in terms of behavior around adolescence.
Mm-hmm.
And so this is the problem we're working on.
It just seems like so many things happening at one time.
Oh, yeah.
So where do you see this going? I mean, or where would you like to see this go? You talk about being able to do early detection, which we know is huge. The sooner you're able to get treatment, it shows statistically the long-term outcomes are much better. But where can you imagine us being in a decade from now?
So the really awesome thing that's happening in neuroscience right now is that with the advancement in technology, we are really incorporating AI into looking and predicting models of how the brain works. And as we get better and better computational hardware, we are getting better and better results in predicting how actual neural activation relates to behaviors. And it's just incredible. We're finding more and more patterns, because what AI can do better than humans, us as scientists, is find these hidden patterns that aren't necessarily obvious given just a ton of information. And so what's happening is that there's more and more collaboration in the field from all of these people who have collected neuroimaging data, and they're compiling them into these databases. And then we're just putting machines to them to see what type of patterns can you pull out when you're looking for this. And it's just amazing. We're breaking down psychiatric disorders like it's never has been before, finding that different brain states are really correlating more towards specific symptoms than necessarily disorders. And so I think you're going to see just a total revamping of how we view psychiatry.
So is that going to translate to better therapies? I mean, how would that?
I hope so.
Yeah, and do you see that being through medication? Do you see it through, I guess, the therapeutic process? I I'm sure it's a combination of you can't swallow a pill and be better. I mean, you can't just sometimes do talk therapy and then all of a sudden you're dealing with these issues. But I guess if you're able to really be able to hone in on very specific targeted areas of the brain that are acting a little differently, causing manifestations of symptoms, how do they do? I mean, how would we begin to target those areas? Would it be through medication? Would it be through other means?
So that's the question, right? Mm-hmm. So, if we find that a specific area of the brain is different in, let's say, depression, and we know that, let's say, this change in this brain activity is then related to, I'm going to use childhood trauma.
Sure.
Then we can then focus on addressing the trauma in the therapy that then will help rework those neural networks, like I said, mm-hmm. and then hopefully address those symptoms that are then the result of this maladaptive behavior because of this trauma, because of these neural networks.
It's interesting that you bring up AI, just to take a half a step backwards, because that is a monumental problem of having endless amounts of data. Mm-hmm. But what does that mean? I mean, how are you going to translate that into something tangible that we can do as neuroscientists, as psychiatrists, as therapists, as engineers and chemists and scientists? How are we going to use that data to actually put that in practical use?
And I think that's the importance of scientists. Big companies can collect tons of data, and we can just sift through it all day and find these patterns. But it takes the scientific process to develop the hypothesis and, based on previous knowledge, say, this is what I think is going to happen, and use that, and then be able to use the tools of AI to test that.
Right.
I mean, it's really putting AI through the scientific process and not just releasing it to see what happens. Mm-hmm. And that's the importance of the scientific method.
So I know that you're also the president of the board of directors for NAMI Arkansas, National Alliance for Mental Illness. Obviously, NAMI is there to help educate and inspire hope in individuals. A lot of the folks that I've worked with and know intimately that are living with mental illness, the one thing that they crave is hope. Mm-hmm. With a future of more science, with more pinpoint accuracy, with being able to sometimes maybe customize medications to the individual rather than just a large blank. I mean, so we're beginning to see a transformation. What do you say to people who are listening that are living with mental illness that are saying, there's nothing that's been there for me, and I don't see in the future anything there to help me? What do you say to those people?
You just have to say that keep looking. No matter what problem it is, there's somebody working on it. And it may be obscure, and it may be in the infant stages of figuring out what's going on, but there is somebody working on it. And the more that, the reason that I got involved with NAMI is because the more that we raise awareness of these issues, the more that we can help address them. And so if these people that, really need hope, I would advise them to just try and educate yourself on what's going on out there in the scientific community. And I know, and this is something that I constantly work with other scientists for, is that a lot of us aren't very good at then taking what's the most current research and breaking it back down into terms that anybody can understand. Mm-hmm. And that's something that we definitely have to get better at, and I am working on that as well. But it also, the individuals who aren't necessarily a part of the scientific community, go out and, there are great publications out there that are geared towards, just the, really breaking science down into things that anyone can understand. And you can find out, the kind of the general idea of what's going on in the field of psychiatry and neuroscience. And that should give you hope because it's incredible.
Well, just promise me that you'll be my psychiatrist. Once you complete that, I want you as my psychiatrist. There are great things coming in the future. Been fortunate enough to be able to talk with you, and then going to conferences that you and I have traveled together to see that there is some amazing things happening out there, and people just do not need to lose hope. No. That they need to know, like you said, someone's working on it. It's been a great pleasure getting to know you, because I want you to be the next Neil deGrasse Tyson of neuroscience. How about that?
I would love it.
Okay, great. And so that's the personal challenge I have to you is that you can become the next Neil deGrasse Tyson of neuroscience. But I do appreciate you.
It is the next frontier.
It is the next frontier. It is. And we do need people, like you said, that can digest some very complicated information and be able to explain it in such a way that people can understand the complexities of it. And it is a very complex system.
Just a little bit.
Just a little bit, right? It's that where there's that learning curve that goes up, but there's only a finite amount of information that any one person can actually learn, but there's an endless amount of information that exists in any one subject. So
there's more connections between neurons in the brain than there are stars in the universe.
And there are a lot of stars in the universe. That's fascinating.
Yeah.
See, that's the Neil deGrasse Tyson type of thing to say, right? Very good. Well, I appreciate you sitting down with us.
Yeah, thank you so much for having me.
And I hope that in the future, as new things start to come out, as new breakthroughs come through, and you see these things in the future, that we begin to share those things with other folks. And so you're always welcome to sit down with me, and we can talk and send this out to folks. Thank you, Brad, and thank you guys for joining us. This is Luke Kramer with the STARR Coalition. We do a podcast every now and then where we bring some incredible folks together that have great things and insights to say about mental health and other issues. So thank you for joining us today. Check back with us at thestarr.org, thestarr.org, for future podcasts and more information about ways that you can be a part of the movement in mental health. Thank you.